Welcome to the chemistry studio. Today's topic is integrated rate law for first order reaction. Let A forms product. Therefore, differential rate will be minus dA over dt. And from rate law, it will be R is equal to K A power 1 for it is first order reaction. From first and second, on equating we get minus dA over dt is equal to Ka. Taking similar terms together, dA over A is equal to K dt. Now integrating both sides, we have to integrate. Therefore, integrating both sides, integration minus dA upon A is equal to K integration dt. We know that integration of 1 by x dx is equal to log x. In chemistry, we take log natural is equal to K integration of dt is t plus some constant c because it is indefinite integral. At t is equal to 0, टाइम जब 0 है तो any concentration must be equal to initial concentration. A naught is initial concentration. Putting in third, we get minus log natural A naught is equal to K into 0 plus C. We get the value of C minus log natural A naught. Again putting in third. When putting in third, we get minus log natural A is equal to minus log natural A naught plus KT. Taking minus log natural to this side, we get log natural A naught minus log natural A is equal to KT. Now we know log A minus log B is equal to log A upon B. Log A upon B is equal to KT. Therefore, K is equal to 1 by T log A naught upon A. This is log natural. In case we convert this log natural to base 10, we will multiply it by 2.303 upon T. Now we can write it as log base 10 A naught upon A. This is integrated rate law for first order reaction. Now half-life denoted by T half. It is the time in which initial concentration is reduced to its half. It means final concentration is equal to half of initial concentration, and T is represented as T half. Putting in fourth equation. Equation K is equal to 2.303 upon T log A naught upon A. इस इक्वेशन में पुट कर देते हैं. We get K is equal to 2.303 T half log A naught upon half A naught. T half will be equal to 2.303 upon K log 2. Now we know the value of log 2. This is 2.303 upon K. Log 2 is 0.3010. Hence T half is equal to, on multiplying these two, we get 0.693 upon K. This is half-life of first order reaction. And we can see clearly that half-life of first order reaction is independent of the initial concentration of the reactant. Half-life of first order reaction is independent of its initial concentration. Now we know that K is equal to 2.303 upon T log A naught upon A. Taking T onto the left side and 2.303 into T is equal to log A naught upon A. On equating this equation with the equation of straight line, y is equal to mx plus c. This is y coordinate. If we plot a graph x, y, log A naught upon A. This is x coordinate, T. As we have no value for c, this is y-intercept. It means graph will start from 0. And slope m, value of m is positive, straight line और slope positive है तो line ऊपर की तरफ. Slope is equal to k upon 2.303. On further simplifying the equation, k upon 2.303 into t is equal to log a upon b is log a minus log b. log a को यहाँ ले आते हैं, इसको यहाँ ले जाते हैं, it becomes log a is equal to log a naught minus k upon 2.303 into t. Again equating it with y is equal to c plus mx. This is y coordinate, this is x coordinate, and slope is negative. On plotting the graph, log a is the y coordinate, t, c intercept, c की कुछ वैल्यू थी तो ग्राफ ऊपर से शुरू होगा, एंड स्लोप वाज नेगेटिव तो ग्राफ नीचे आएगा. c की वैल्यू थी log a naught, और स्लोप है हमारे पास -k/2.303. Now integrated rate law for zero order reaction. Again, let A forms product, differential rate will remain the same, dA/dt. Rate law is equal to K, for it is zero order reaction. From first and second, minus dA/dt is equal to K. Now taking the similar terms together, minus dA is equal to K dt. Integrating both sides, minus integration dA is equal to K integration dt. On integration it becomes minus A kt plus some constant C. At t is equal to 0, final concentration is equal to initial concentration. This is initial concentration. जब टाइम 0 है तो कोई भी concentration वो initial होगी. Putting in third, में इसे पुट कर देते हैं. थर्ड में पुट किया, we get minus A0 is equal to K into 0 plus C. C is equal to minus A0. C की वैल्यू आ गई. Again putting in third, minus A is equal to KT minus A0. माइनस A0 को इस तरफ ले जाते हैं. A0 माइनस A इज इक्वल टू KT. T को अपॉन में ले आओ. A0 माइनस A अपॉन T is equal to K. This is integrated rate law for zero order reaction. Now half-life. Half-life T half, when T is equal to T half, final concentration is equal to half of initial concentration. Putting in fourth, K is equal to A0 minus 1 by 2 A0 upon T half. T half therefore is equal to 1 by 2 A0 upon K. This is half-life for zero order reaction, and we can see clearly that the half-life of zero order depends upon the initial concentration of the reactant. Now again for zero order reaction, K is equal to A0 minus A on T. KT is equal to A0 minus A ए को इस तरफ और के टी को यहाँ ले जाते हैं, इट बिकम्स ए इज इक्वल टू ए नॉट माइनस के टी। एक्स वाई, फिर इक्वेट करते हैं बेटे, वाई इज इक्वल टू सी प्लस एम एक्स। वाई कोऑर्डिनेट, दिस इज एक्स कोऑर्डिनेट। एक्स कोऑर्डिनेट हमारे पास है टी 0। सी की कुछ वैल्यू, ग्राफ ऊपर से शुरू होगा, स्लोप नेगेटिव है, ग्राफ नीचे आएगा। स्लोप है हमारे पास माइनस के, और ये वैल्यू आ गई हमारे पास ए नॉट। तो ये हो गया हमारे पास जीरो ऑर्डर का ग्राफ। नाउ नेक्स्ट इज इंटीग्रेटेड रेट लॉ फॉर गैसेस सिस्टम फर्स्ट ऑर्डर। इंटीग्रेटेड रेट लॉ फॉर फर्स्ट ऑर्डर गैसियस सिस्टम। गैसियस सिस्टम के लिए हम निकाल रहे हैं, फर्स्ट ऑर्डर है, हमें पहले से पता है, ए बी गैस gets split to form A gas and B gas. Let initial pressure is Pi and the initial pressure of A and B is 0. X amount of AB gas splits to form X amount of A and X amount of B. ये 1 मोल है, ये भी 1 मोल और ये भी 1 मोल बनेगा। तो अगर ये X अमाउंट स्प्लिट होता है तो ये भी X और ये भी X बनेगा। तो देयरफॉर टोटल प्रेशर P total will be equal to sum of these three, A का प्रेशर, B का प्रेशर और AB का जो प्रेशर बच गया। तो टोटल प्रेशर PI माइनस एक्स प्लस एक्स प्लस एक्स। तो P टोटल विल बी इक्वल टू PI प्लस एक्स। तो x की वैल्यू हमारे पास आ गई P टोटल माइनस PI। तो फाइनल प्रेशर कितना हो गया, ये बेटा ये इनिशियल था and this is final. Final pressure will be, we know that final pressure is Pi minus x. Putting the value of x, we get Pi minus P total plus Pi. It becomes 2Pi minus P total. Now we know the integrated rate law, K is equal to 2.303 upon T log initial upon final. So this is initial pressure and this is final pressure, 2Pi minus P total. This is integrated rate law for first order gaseous system. Now next topic is effect of temperature on K. With increase in temperature, kinetic energy of the molecules increases, therefore the number of collisions increases, due to which rate of reaction increases. But the rate depends upon effective collisions. Effective collision, the collision in which molecules collide with sufficient kinetic energy and proper orientation. So as to break the bonds among reactant molecules and form the bonds between product molecules. ऐसा कोलिजन इफेक्टिव कोलिजन होता है. दो कंडीशन रिक्वायर्ड है हमारे पास. दे मस्ट हैव सफिशिएंट काइनेटिक एनर्जी एंड प्रॉपर ओरिएंटेशन. ओरिएंटेशन इन द सेंस they must collide like these two particles. If they are colliding like this, there will be no product formation, even though they have sufficient kinetic energy. They must be in proper orientation so as to collide to form product. So we require proper orientation along with sufficient kinetic energy. It has been observed that for each 10-degree rise in temperature, the rate becomes almost double. The temperature dependence of K is given by Arrhenius equation. Arrhenius equation K is equal to A exponential minus EA upon RT. K is rate constant. A is Arrhenius factor or pre-exponential factor. EA is activation energy. अभी डिस्कस करेंगे क्या होता है. R is gas constant. T is temperature. Now taking log on both sides, we can solve this equation after taking log on both sides. Now what is activation energy? Activation energy it is the minimum amount of energy required to form activated complex. Activated complex means intermediate. Or to gain threshold energy. Threshold energy is the minimum energy required to form product. If we plot the graph, x-axis, y-axis, this is scale of energy, and these are reaction coordinates. Reaction coordinates, reactant, intermediate, and product. The energy possessed by the reactant molecules is called average energy. And the energy required to form product is called threshold energy. So this required amount of energy by the reactant molecules to attain threshold energy, this required amount of energy is called activation energy. At this point, the reactant particles, they are converted into activated complex. At this point, they are converted into activated complex. And when they start forming bonds, their energy decreases. This is the graph of exothermic reaction. Exothermic, because the energy of the product is less than the energy of the reactant. But if the energy is more than the average energy of the reactant, this is the graph for the endothermic reaction. At this point, activated complex is formed. Activated complex. Now, taking log on both sides, in Arrhenius equation, log natural k log natural a exponential minus E upon RT. Log natural k is equal to log a into b is log a plus log b. Log natural k is equal to log natural a. Log a power x is x log a. Therefore, it becomes minus Ea upon RT log natural E. And we know that log natural E is 1. Now it becomes log natural k is equal to log natural a minus Ea upon RT. Converting the log natural into base 10, it becomes 2.303 log k, 2.303 log a, this is log a minus Ea upon minus Ea upon RT. Now dividing the equation by 2.303, we get log k is equal to log a minus Ea upon 2.303 RT. Now again equating the equation with the equation of straight line, y is equal to c plus mx. This y coordinate, log k, x coordinate 1 by t. We have value of y intercept. It means ग्राफ ऊपर से शुरू होगा, स्लोप इज नेगेटिव. Slope is minus EA upon 2.303 r, and this is the value of log a. Now again let K1 is rate constant at temperature T1 and K2 is rate constant at temperature T2. So therefore log K1 is equal to log A minus EA upon 2.303 r 1 upon T1. Log K2 is equal to log A minus EA upon 2.303 r 1 upon T2. Second minus first. Log K2 minus log K1, it becomes log K2 upon K1. Log A cancel. Taking minus EA upon 2.303 r common, we get 1 upon T1 minus 1 upon T2. This is the final equation. Oh, sorry, it is EA. E upon 2.33 r 1 upon T1 minus 1 upon T2. That is all for today. Thank you for watching.